we're going to take a look at a method for comparing degrees and radians. This is what we have recently learned, is how to deal with, or basically we've learned what radians are and can kind of think of them in comparison of our current understanding of degrees. So let's answer some of these questions thinking about that. So for part A, the first part here says, how many degrees of angle measure are there in half of a circle? So that we can visualize this, let's take a look at a circle and sort of show the quadrants. How many degrees are there in half a circle? Well, that's 180 degrees. Okay, about how many radians of angle measure are there in half a circle? Well, we've discovered that if we go halfway around, that's 3 and a little bit more, 3.14 radians. Okay, exactly how many radians of angle measure are there in one half of a circle? The exact is pi. Pi is exact, it's not rounded. 3.14 is a rounded value. Part B, write an equation that relates radians and degrees using the half circle. So if we take a look at the half circle, halfway around in radians is pi, halfway around in degrees is 180, so I believe my equation would look like pi is equal to 180 degrees. Part C, use this relationship to convert pi over 3 radians into degrees. Okay, well, we can do that by setting up a ratio that will cancel out our pi. So if these are equal to each other, I can write a giant 1 by saying 180 over pi. This is equal to 1, just in two different units. This is in degrees and this is in radians. So the pi values cancel out and I get 180 over 3, which reduces to 60 degrees. Part D, how many radians are there in 200 pi given an exact value? Now we'd like to convert from degrees into radians. So we want our radian value on the numerator of the giant 1, the fraction, so that we end up with pi back again. Multiply across the top and that's 200 pi over 180, and we can simplify that, divide by 10. That makes 20 over 18, which would be 10 pi over 9. Got to remember those fractions. Fractions are very important in trigonometry. Okay, so in your notes, you need to have that written down, that value that we've been talking about, that ratio. Write down that pi is equal to 180 degrees. And note that to go one direction, if you want to change something into degrees, you do 180 over pi. If you want to change it into radians, you do pi over 180, multiply. Okay, so you should have an intuitive sense about how many degrees are in 1 radian, since you, actually this got a little bit chopped off, so let's change the size of it. There we go, now we can read all of it. Okay, how many degrees are in 1 radian accurate to 3 decimal places? Okay, so to calculate that, we want to know degrees in 1 radian. That's 3.14. Put that in the calculator, and that gives us 57.296 degrees, accurate to 3 decimal places. Well, B would be the reverse of that. So pi divided by 180. 3.14, or the pi button in the calculator, divided by 180. We end up with 0.017. So this is how many degrees there are to 1 radian. This is how many radians there are to 1 degree. So which one is much smaller? A degree is much smaller. Degrees are very small. 90 of them fit in a right angle. Radians are much larger. Only about 1.5 fits in a right angle. All right, let's practice doing some conversions. So we want to convert these degree measures into radians. So to go into radians, we want pi in the numerator. So multiply 180 times pi over 180, and we get pi. And if you think about that intuitively, that should make sense. 180 degrees is equal to pi radians. So on this one, we're going to multiply by pi over 180 again. And we end up with negative because this one's negative, and we simplify. We get pi over 5. And on this one, same again, we're going to multiply by pi over 180. You can pretend that's over 1 if that helps out. Multiply across the top, we get 2 pi squared. Pi times pi is pi squared over 180. And the 2 and the 180 can simplify to be pi squared over 90. All right, so convert from degree to radians, multiply by pi over 180. Now we're going to do from radians to degrees. So we multiply by 180 over pi. Pi's cancel out. We can simplify 180 divided by 2 makes 90, and times 3 leaves us with 270 degrees. Again, 180 times pi. Pi's cancel out, and we can simplify 7 times 180 divide by 6, and that's negative 210 degrees. And here, 2 times 180 over pi. This one seems really weird, but it works out. 2 times 180, 360 over pi. There we have it. All right. Now, a problem that we can apply this to. We have a wheel spinning at 500 revolutions per minute. So I'm going to write down a ratio, 500 revolutions in 1 minute, but I want to know how many radians per second. So how could I write seconds instead of minutes? So if it's 500 revolutions in 1 minute, that's the same as 500 revolutions in 60 seconds. Let's go ahead and put REV for revolutions. So 500 revolutions per 60 seconds. Now, 1 revolution equals pi radians. So each of these 500 revolutions goes 2 pi radians. I meant 2 pi radians goes 2 pi radians. So multiply that by 2 pi and simplify. So we end up with 1,000 pi per 60 seconds. So how many in 1 second? That reduces to exactly 50 pi over 3 radians per second. Okay. Now, this is using that resource page that I gave you, the large circle. And it's this one right here. So we're going to see about what all the radian measures are on a unit circle going all the way around. So the first part, A, find the radian measures of the angles that are on the axes, and start by thinking about that 2 pi is 1 full revolution. So let's take a look at that. Oh, it's too large. I need to shrink this. so we can see it better. I wonder if I have, nope, bummer. Okay. So when we think about going one full circle, that's 2 pi radians. If we haven't gone anywhere yet, it's 0. So these are coterminal angles, 0 and 2 pi. They land in the same spot. Okay, if we go one, now remember we always go counterclockwise. 1/2 of a circle, we've made it pi radians. So if we want to go half of that, that makes it pi over 2. Okay, so another way to think of the entire circle is to think of that we have 1/2 of a circle is 1 full pi. So a whole circle is 2 pi. So think of this as this piece is a half, 1/2. Here's 2 halves. 2 halves, 2 over 2 reduces to 1, so there's 1 pi. And once we get down to here, now we have 3 halves. So this is 3 pi over 2. And then this is 4 halves of this of a pi, and that ends up being 2 pi. Okay, takes some getting used to. Let's go back and then let's fill out the rest of it. Okay, B, find the measures that are in the center of each quadrant. So now we're going to look at basically the fourths. So let's go back to our circle. We want to focus on these parts right here. Here's 0/4. Here's 1/4. So if it's 1/4 pi, that can be written as pi over 4. Here's 2/4. So think about that. 2/4. Does 2 over 4 reduce to 1 over 2? Same thing. Okay, and now the next fourth right here, 3/4. And that does not reduce. That fraction 3 over 4 does not reduce. How many fourths here? That's 4/4. 4 over 4 makes 1. This one, 5/4. So we have 5 pi over 4. That does not reduce. 6/4. Okay, 6/4 is the same as 3 halves. Right here, 6/4, 7/4. And that got us all of those markings. These are all of the special angles that we need to learn and memorize in trig. Okay, so the last one here, let's take a look at knowing that 1/2 of a circle is pi radians. Divide the top half of the circle into 6 equal pieces. So we're dealing with fractions that are sixths this time. And we're going to use that information to do the upper part, and then we'll keep going around the circle. Okay, so thinking of sixths. So here's 0/6. Here's 1/6 of the circle. 1/6 pi. Now this is a fourth, it's not a sixth, so we jump to this one. Because if we're thinking of dividing it into 6 pieces, here's 1/6, 2/6, 3/6, 4/6, 5/6. Okay, so 1, 2, 3, 4, 5, 6/6 makes the whole. So 1/6, 2/6. Think about the fraction 2/6. 2/6 reduces to 1/3. So that's pi over 3. Right here, that was 2/6. This is 3/6. 3/6 is the same as 1/2. So we've already got that one labeled. 4/6 is what we have here. 4/6 reduces to 2/3. So we've got 2 pi over 3. This one right here, we've got, that was 1/6, 2/6, 3/6, 4/6, 5/6 pi. This is 6/6 pi. Isn't 6 over 6 the same as 1 pi? All right, now we can keep going around the circle. Now we've got more than a whole pi, so we've got 7/6 pi here. This spot's 8/6, and that's reducible. 8/6 is the same as 4/3. 9/6, is that the same as 3/2? Yes, we've already labeled that one. 10/6, 5/3. 11/6 does not reduce. And there we have it. This is the entire circle. All of these radian measures are what we need to memorize. So get those memorized, study this, see if you can draw your own circle and label them all yourselves, quiz yourself, try it again and again. Draw a new circle just like this. Go, okay, here's my new circle. I know that this is 1/4 pi, 2/4, 3/4, 4/4, which is pi, 5/4, 6/4 reduces to 3/2, 7/4, and then go back through doing the sixths. So next comes 1/6, 2/6, which reduces, 3/6, 4/6, which reduces, 5/6, here's 6/6, 7/6, 8/6, 9/6, 10/6, and 11/6. Practice that again and again. Get it memorized. It's very important. Okay, that's it for now. Bye.